Hey everyone and welcome to the channel. I've been itching to get my hands on a fly cutter ever since I found out they're a thing. All the machining guys I watch on YouTube seem to have one, and at risk of not being one of the cool kids, I guess it's time to have a go at making one myself. If that sounds like something you're into, hang around to see how this one turns out. This isn't going to be one of those massive fly cutters that you see, although I would like to make one of those someday when I need it. But I do want to make a smaller fly cutter that I can use daily, and is durable enough that it's around for years to come. So for the body, I'm going to have my first try at 4140 Chromoly. Hopefully using something with a little chrome should help it be a little bit more corrosion resistant, and I'm led to believe that it's pretty high in tensile strength. I've got myself a 60-ish mil piece of round stock that I'll face off. I don't know what that tape's made of, but it seems to be pretty tough stuff in its own right. Then I can reduce the shank. I want to be able to mount this in an ER32 collet, so I'll just bring down the shank to a hair under 20mm. This lathe isn't the biggest and baddest thing on the planet, but as far as small machines go, I guess it's on the bigger end, and it's handling the Chromoly okay, but there aren't any big deep cuts on this stuff. I tried pushing up to about 2mm depth of cut, and I could just do it, but the lathe was on the edge of stalling out. But I'm in no rush, so we can just whittle this one down 1mm at a time. That collet fits on there pretty nice, and the shank should be well within its range. So I can clean up the top face with a few light passes. It did not want to break a chip at all. I'm surprised it didn't end up with a family of magpies in here. Then I can break all the hard corners and get this flipped over in the collet chuck. Then we can face the bottom, take a skim pass off the body, and that's all the lathing done. Now I can go into a collet block on a 10-degree angle and start bringing this face down to flat. A new tool for me on this one is some cheap roughing mills, and they're awesome. I took one small cut without coolant and it got hot really fast. Also the chips dry were a nightmare. But with a little coolant, I'm really amazed at how these can eat up this 4140. But the surface finish is pretty rough, and I don't have a fly cutter, yet. But in a pinch, I found that if I take 2 of the 3 inserts out of this little facing cutter that came with the mill, I can get a somewhat okay finish. With the main face cleaned up, I can find centre and offset just under the centre line where the 12mm roughing mill and get to work on the slot that's going to make room for the tool holder. There doesn't seem to be a huge number of rules when it comes to how to make a fly cutter, but one that pops up on all of them is keeping the cutting face of the tool at centre line. You can fudge it a little if you go over the line by setting the cutting tool a little deeper into the holder to space it out. But the closer to centre, the better. And rather than make this fit any other tooling, I went with the universally acceptable 14mm for the tool holder, so I can just work out a little slot until it's right on the money. I could have made this a lot smaller. I watched a lot of videos by guys that actually know what they're doing before tackling this one, and 12mm seems to be pretty common for most when it comes to their holder thickness. But I figure more rigidity and mass can't be a bad thing here, and it seemed to give me a happy medium of material left on the outside edge for support. And then over to the opposing edge to remove some material for some set screws. I got a little carried away here. I liked how the camera was looking for this cut from this side with the lighting in the background, and tried to take a pretty deep climb cut, and got most of the way across before... Not only did it leave me with a heap of cool scars on the piece, and I had to re-indicate the part back in, but something else happened that wasn't apparent to me at the time. That'll come back to haunt me a little further into the project. But conventional milling seemed to do the trick, and now I can switch over to a regular 4 flute end mill to try and clean up that mess. It's not perfect, and I didn't really want to go any thinner after having to square up after my little roughing mill jump, but it's a bit cleaner than when I started. Then we can knock off all the main edges with a file, and flip it onto its side to get the holes drilled for the set screws. I'll just center drill, then run a pilot through for an M6 tap, a little counterbore with an end mill for a hex head bolt, a little chamfer, then I can run through a tap. And that sits in there pretty nice. So I'll just repeat the process to give me 2 more holes. And that's the fly part of the fly cutter done. And now for the tool holder. I don't have anything fancy in the ways of steels in square or bar form, so hot rolled plate it is. I'll square it up a bit, and then get to work on the slot for the set screws to sit into. I get that people braver than me probably don't do this step, but the idea of a piece of square bar spinning around like a helicopter blade with a carbide insert in the end, unsupported, sound like it could end in a home shop vasectomy. With a little channel in here, the ends of the bolts should lock everything down, and if everything comes flying apart, at the very least the bar shouldn't exit the main body of the cutter. And now you can just make out in this shot where that little accident from earlier is going to come back to bite me. It's a little hard to see, but the slot I just cut is nowhere close to straight. The guy that's making this hasn't noticed it yet. With my powers of hindsight, you can see that the slot is heaps closer to the edge on one end than the other. When that roughing mill grabbed earlier, it knocked my vise all out of whack. I didn't check it at the time, but thankfully it hasn't seemed to have affected the body of the cutter. And just to rub a little salt into the wound, I wanted the slot to stop with a little bit of an overhang on one end, and I've managed to cut this one on the wrong side. It's mostly aesthetic, but not what I had in mind at all. Nailed it. But I'll rush through another with the vise trammed in and cut the slot on the right side. And that's looking much better and closer to what I had in mind. Now I can make a little home for this insert. I'll find my spot with an edge finder and get a hole drilled for the screw. Then plunge in a little round area for the insert to sit in. I do want to take a quick moment here to talk about insert geometry. I get that this is one of those topics that everyone feels a little bit different about, but I just want to take a little moment to look at this insert and talk about geometry. Fly cutters would usually have a little bit of back rake on the tool to reduce the tool pressure on the edge. The more you lean them back, the sharper in essence it makes the tool, but it also makes the edge a little weaker. This insert has a little bit of angle worked into the top face, so it has a slight angle built into its own design. If you were going to do this with an insert that had no rake built in, you would have to set this in on a bit of an angle. And they're all different for the material you're cutting and the inserts that you're using. Because I'm mostly making things from steel and want as strong of a tool as I can get, I'm going to mount this one so it'll approach the cut at 90 degrees, and the angles built into the insert should sort everything out. Well, that's the idea I'm running with. If you actually know what you're talking about, let me know in the comments below if I missed anything. But with the little recess set for the insert, I'll pop over to the belt grinder and round that bottom corner over to match the base of the insert. Then clean up the outside edges to be at the same 10-degree angle that the body of the cutter is, so it looks like I had a plan. Then the last little bit of machining, I'll whiz off the excess at the bottom of the holder so it fits nicely inside the slot in the body. For the record, this is the most I've ever used coolant before, and the difference in tool life is night and day. It's not perfect for filming, although it does look kinda cool in its own right, but as a hobbyist that needs to stretch every dollar in this shop, I think I'll be using it a lot more in the future. Then a little more rounding on the belt grinder to clean that up, and a little filing to knock off the hard edges, and we're done. This fly cutter was a lot of fun to make, and I'm pretty happy with how it looks, but none of that means anything if it can't do its job, so let's put it to work. With my usual lack of planning, I don't really have anything with a big surface area handy to test this on, but I figure I'll need a bit of messing around with the speeds and feeds to get this right, so this little bit of scrap should do the trick. And to be honest, it took a lot more fluffing around than normal for me to get this to work, and I still think I can get it a bit better. But the best setup I found was about 500 RPM with light cuts, somewhere around 1/4 of a mil depth of cut and a moderate feed rate, which I know is vague, but I'm hand feeding, and I was doing about 1 3 count per rotation of the hand wheel, which is 3 mil, for anyone weird like me that measures feeds like that. And I call the finish fairly good. This is a piece of hot rolled, which I don't think I've ever gotten a good finish on, and that's far better than anything I've ever managed to get before, so I guess we're heading in the right direction. Thanks for watching the video, everyone. If you liked it, please consider giving the video a like and subscribing to the channel. See you on the next one!